Hey everybody, that's the example of triboelectric charging and electrostatic induction. That's just some really fancy ways of saying methods of charging, or how do objects gain and lose charge. And that's what we're going to be investigating today. All right, there are 3 methods of charging, 4 if you include grounding. Right here I've got this PVC and I need to charge it up. PVC actually has a high affinity for electrons, which means that it can gain electrons fairly easily. Think about it as we can put electrons onto it. Charges aren't going to flow onto it very easily because it's an insulator. However, if I do put electrons onto it, those electrons are not going to move on this. They're going to stay right where I put them. So where could I get some electrons? Carl! Electrons! Come here.
All right, Carl is kind enough to give us some of his electrons. So we've got a PVC pipe right here. All right, that should do, buddy. All right, now the PVC is negatively charged, and I'm going to prove it to you by bringing it next to these pieces of paper.
All right, you might be wondering, how were those pieces of paper attracted to the negatively charged PVC? We can assume that these pieces of paper are neutral charge. So how can things that are neutral be attracted to objects that have a charge? Well, the way that's possible is because of electrostatic induction, or charge by induction. And a better example for that is the can and the PVC that we did earlier. So we're gonna break that down.
Thanks to Carl. Carl was able to give us a bunch of electrons for the PVC, giving it a net overall negative charge. And you've noticed when I brought the PVC towards the can that the can accelerated to the right, towards the PVC. All right, this is because of electrostatic induction. And induction occurs when a charged object, that being the PVC, is brought near a neutral object, which is the can, but does not touch it. Just the mere presence of the charged object near the can, it forces or induces the electrons inside the can to move, okay? So I'm going to erase all of these negative charges that are already in here, and I'm just going to move them to the left side, okay? Remember, the protons are locked inside the atom. They cannot move. But the electrons, those free electrons, they can. And the aluminum can is a conductor. So those electrons want to move as far away from that PVC as possible. And so what happens is, since those electrons move away from the PVC, the protons are much closer. And since they're closer to the PVC, that's a stronger force of attraction. And we're going to get into that once we learn Coulomb's law in the next video. So that is electrostatic induction. All right, moving on to charge by friction. We kind of already covered this, and it's fairly straightforward. But charge by friction occurs when two objects, they're rubbed together to transfer electrons. Okay? And so if this occurs with two neutral objects, one being the PVC and the other one being Carl, well, we know that Carl's fur has a low affinity for electrons, so he would prefer to give electrons to the PVC. So now Carl becomes positively charged, and then the PVC is negatively charged. So you've heard me say affinity for electrons a couple times, but what does that actually mean? So every object or every material has a certain affinity for electrons. And so in order of affinity, we call this triboelectric series right here. Okay, all of these objects are ordered by their affinity for electrons. And what that means is that objects with a high affinity means they have a tendency to take electrons. Whereas on the bottom of the list, objects have a low affinity, which means they want to give electrons, okay? And if we were to charge by friction, take two of these objects and rub them together, the object at the top, which has a high affinity, will take electrons from the one that's towards the bottom. So that the object that's at the top of the list will become more negative because it's taking electrons, and the object that's toward the bottom of the list will become more positive because it is giving electrons. All right, and that's what I mean by affinity for electrons. This last charging method is charge by conduction. All right, and this picture right here is actually a fun fly stick, and I'm going to show you in just a moment. But it is battery powered, and this usually occurs with conductors because charges flow on and through them fairly easily. Well, this conduction rod, or this fun fly stick, whatever you want to call it, it gives electrons, and this is aluminum foil. And since it is in contact with the rod, and it's aluminum foil, that's a conductor. That means all of these electrons can easily pass and flow on this aluminum foil. And you notice that it's got this like circular shape. Well, this is a continuous circle of aluminum foil. And as we put more electrons onto it, the electrons don't want to be by each other. So they're gonna stretch out as far as they can, and this actually becomes a circle, okay? And I'm gonna show you in the video. So charge by conduction means when two objects touch or come into contact, they are immediately transferred. And this usually occurs with conductors, okay? So when conductors are given charges through contact or conduction, those charges that are placed onto it immediately disperse throughout that object, okay? The charges want to reach an equilibrium. They don't want to have a concentration of charges on one side if they don't have to. If the charges can flow on it easily, they're going to spread out as fast as they can. So right here, we've got what's called the Fun Fly Stick. You can get these things on Amazon. I'm pretty sure this is a knockoff brand. You get 2 of them for like 10 bucks. Great deal. Super fun to play with. So basically how this works, on the inside, it's got a battery. And connected to that battery is like a rubber belt, which then brings the electrons from down by the battery all the way up towards the end of the rod, to the conduction part. And then once there, those electrons can then be passed on through charge by conduction onto the aluminum foil. All right, all I gotta do is press this button, and you can see it immediately, you can hear it, those electrons passing, and now those electrons don't wanna be by the other ones, so it kind of stretches out the aluminum foil. And so what I gotta do here is kind of shake it off. Sometimes it's a little challenging to do that. Whoop. There we go. Now you got this hovering effect. All right.
So you saw the hovering effect from the aluminum foil and the Fun Fly Stick. That was able to happen because the Fun Fly Stick was able to transfer enough electrons onto the aluminum foil. What was really cool about that is that this aluminum foil has a little bit of weight. But the electrostatic force exerted between these two objects, the magnitude of that force was stronger than the magnitude of this weight, which is pretty cool. It caused it to float and hover in the air. And so what we're gonna do next is look at and explore the electroscope. All right, this is a common tool, common demonstration for static electricity, and we're gonna get into this, and it's gonna tie everything together as well as introduce you to grounding. All right, so here's an electroscope. Pretty much the entire electroscope is a conductor, so it can pass charges fairly easily. So I'm gonna use here is the Fun Fly Stick. I tried using a PVC earlier, but I just could not get enough charge. So what I'm gonna do is charge up the PVC and then bring it near the top of the electroscope, but not touch. See, what you see here is that metal piece in the middle, that started to move. Because basically what's happening is the electrons in the Fun Fly Stick are inducing a charge in the electroscope. So since this is all metal, the electrons in the electroscope that are up here, they don't want to be next to the Fun Fly Stick, so they all move way down here. So what you've noticed is when I charge this up, bring it near, that piece moves, and then when I take it away, it moves back, okay? So what I'm gonna do next is charge it up and make contact, or do charge by conduction, okay? And then you can see what happens. All right. So I made contact with it, and so I gave the electroscope a lot of negative charges, and then I removed the Fun Fly Stick. So what happened here is all of these electrons are now everywhere in the electroscope. So this part is negative and this part is negative. Every part is negative, and now this metal piece in the middle doesn't want to be close to the vertical piece, which is quite interesting. And so if I want to remove charge or ground the electroscope, all I have to do is touch anywhere on here, because my body has a much larger surface area than the electroscope and somewhat conductive. So those charges can easily be taken onto my body and removed from the electroscope, rendering it neutral. And as you see, that piece goes back to where it was. So that's the electroscope, and remember, grounding is the removal of charge.